All right. I'm assuming everyone can hear me and see the slide share. Awesome. All right. Well, let's jump in. I'm assuming, Alex, you'll tell me if it's not sharing. So really excited to talk to you all. Today's talk is really about the challenges of scale from a security standpoint as organizations adopt Terraform and mature in their cloud journey. But before we jump in, let me talk a little bit about myself and why I'm giving this talk. So I've been in the information security industry for almost 2 decades, seen a number of organizations go through incredible transformations as they modernize. My background, as Alex said, right, I started off in research, did a lot of research in topics like trusted computing, as an example, and then joined the corporate world and really focused on building security practices, especially security architecture practices. And a big focus of mine over my last decade of working has been, how does security fit into modern development practices? And that naturally led me and my co-founders to found Oak9, which really focuses in this area. And currently I am CTO and co-founder of Oak9, and I spend my time focusing on security as code and really building capabilities that security organizations can adopt to better support modern development practices. So what is Oak9? Just for some background, we are a cloud-native security as code automation platform. Think of us as an automated security architect that sits on that Terraform developer's shoulder as they're writing Terraform. We guide them towards better security and compliance-focused decisions. And throughout the entire lifecycle, as changes are made to that code, we can come in and help remediate security issues, but more importantly, align that architecture to the best practices that the organization wants to follow to make sure that they're meeting their business and security objectives. So, talking about scale, I want to start with just kind of setting some context and what we're seeing in the industry today. We are seeing an incredible rise in cloud security incidents. Last year, 45% of all breaches occurred in the cloud. And, these trends, I'm sure everyone reads the news and you're well familiar, but really, why is this happening? This is happening because, today we are building architectures that are of this incredible complexity and size. If we were to measure the entropy of the types of architectures that organizations build from a decade ago to now, you would see that entropy exponentially rise, and very much aligned with the adoption of cloud and the adoption of languages like Terraform. And what we're seeing is just a lot of rapid change in the organizations. There's a lot of change from the cloud service provider side. Terraform providers change on a day-to-day basis, and really, it's really hard for security teams to keep up. And we'll talk about what I'm seeing on the ground as I talk to customers here. But to set more context, really, in modern development life cycles, infrastructure and entire application architectures are now designed and delivered as code in languages like Terraform. And more, Terraform is falling under the umbrella of software development, which means we're affording it all of the best practices that we have learned over the last decade on how to build software on the application side to infrastructure as code like Terraform. And what's happening is entire application architectures, large-scale architectures, are now entirely codified in Terraform. And these architectures, unlike 10 years ago, are no longer static. They are continuously evolving on a day-to-day basis, on a sprint-to-sprint basis, on a release-to-release basis. Fundamentally, these architectures are changing, and that makes security's job that much harder to assess these architectures to make sure that security and compliance objectives are being met. A lot of other challenges, that organizations face are that security engineers are not necessarily experts in Terraform. They might not even have the necessary expertise in a multi-cloud environment to understand all of the different feature capabilities that developers want to adopt. And fundamentally, security teams have really struggled to keep up And that leads to a natural friction between security and development, as development really has to slow down to make sure that security can catch up and provide the necessary guidance so that what's being delivered is risk appropriately secure. So this talk is really about building modern security practices that scale. And on a day-to-day basis, over the last 5 years, I've spent my time talking to customers, really engaging customers to understand the challenges that they have just as part of my role. And what I'm seeing across the spectrum is organizations really going through their IAC adoption and cloud journey and trying to build modern security practices that scale to some of the challenges that I'll talk about. And this talk is really about those challenges as well as some of the lessons learned that over the last 5 years of just observing how companies have adopted and adapted to some of the changes that are happening in the industry. So, in true form of a top 10 list, I'll start with the first item. The most common issue I see across all of the conversations I have and most of the customers that I talk to is one of culture. There's a lot of organizations that still have silos between dev and ops or dev and security, and those silos naturally inhibit collaboration. And what you see is in organizations that are actually doing this well is the cultural change actually happens from the top down. There are champions at the leadership level that really drive this change. They understand the value of investing in developer champions and security champions. They understand the value of democratizing security and making security more inclusive across different stakeholders, including developers. And so you just see a natural cultural shift in organizations that are really kind of doing more bleeding edge work as a modern security practice. The other kind of challenge that I see a lot of organizations face is as they're kind of in the middle of their journey, as they're looking to really adopt the right operating model from an IT standpoint, they're struggling to decide, well, what is the right operating model for my organization? Do I need a cloud center of excellence, or is platform teams and platform engineering really the right model for me? And I can tell you that across many customers, I see all sorts of operating models, and really that operating model needs to be aligned to your goals. Most importantly, your teams and your culture and how your organization operates. The second biggest thing that I see is really most organizations today invest in reactive security tooling. So what happens is you go through the entire development lifecycle, you design, build, you deploy, and then months later, security uses some reactive tool to find a bunch of issues, and that comes back to the development team to then get fixed. And that incurs an incredible cost. So what we know from data is that this is 100 times more costly than if that issue would have been addressed at the design and code phase. And fundamentally shifting left and really looking at the Terraform that's being built and understanding whether it is aligning with your security and compliance best practices is going to reduce your overall cost of addressing security. But more importantly, it leads to higher velocity and agility. And so more and more studies continue to kind of show that if you can shift left, and you can really shift left all the way to the design, you can reduce your overall cost, improve your business velocity as well as agility. The third kind of common thing I see from a challenge standpoint is the predominant approach to solving security in the cloud has been static misconfiguration checking. And I'll define what that means. But essentially, what you do is you identify configurations that are security relevant. You create rule sets that say, hey, this configuration should always be set to this value. And you create a rule set of thousands of these configurations. And then, indiscriminately, you apply this rule set to every single resource and deployment you see. And so in a large scale environment where you might have hundreds of thousands of resources, imagine if every resource had 5 to 10 false positives. Imagine the experience that that developer has when they're being inundated with issues that actually aren't issues. And if someone just understood their business use case, if someone just understood the architecture they're trying to build in Terraform, they would understand that that is actually not a security issue. And, they wouldn't report on it. And so fundamentally, focusing on design as opposed to focusing on misconfiguration checking and really thinking about Terraform, not as configuration as code, but thinking about Terraform as architecture as code. And if you start doing that, then what you're going to focus on from a security standpoint, and this is what modern security practices that I interact with do, they think about building design patterns. They think about really building patterns that their developers can adopt, building catalogs of patterns. And what we have seen, there was a talk at RSA last year, and our own data proves this, is when you focus on design and when you focus on building design patterns, you will see over a 50% reduction in the cost of delivering security. And if there are any security engineers in the audience, that typically, in a resource-constrained security team, that is a huge benefit. The other kind of set of challenges that I see continuously is really the continuous evolution. There is just a lot of change happening very fast. So if you look at cloud service providers like AWS, Azure, or GCP, there isn't a single day in the calendar year where they're not making a change to one of their feature capabilities. If you just observe how quickly and rapidly Terraform providers are evolving, on a weekly basis, you see multiple changes to those Terraform providers. What you see on a business standpoint is as businesses are really modernizing and following agile practices, what's changing is business requirements are changing pretty rapidly. Technology requirements change fairly rapidly as IT continues to reevaluate its technology strategy. And then on a security side, businesses are going through a lot of change where regulatory landscapes are changing, the threat landscape that they operate in changes. And so security requirements are changing pretty rapidly. And all of this really leads to a lot of change that's happening to your application architectures. And really the only way for resource-constrained security teams to scale in this case is to embrace automation. You have to embrace automation. You have to really think automation first, and you have to build continuous improvement processes that help you continue to evolve and improve the overall security posture of your organization. And speaking of embracing automation, really, I talked about the scale and complexity of these modern architectures today. It is impossible for security teams to keep up with the amount of churn as well as the size of these applications. So if you look at surveys, what we see is on average in the industry, there are 100 developers to one security engineer. That security engineer just cannot keep up with the amount of change that is happening. Every single security organization, even today, is resource constrained. And really the only way they can scale is automation. So when I look at the spectrum of organizations that I work with, the modern security organizations have really embraced automation because they recognize that automation is really the only way to scale to this problem. The other aspect of automation, and really going back to that cultural aspect as well, is to really democratize security for developers and think about the developer's experience first and fit into their workflows. I'm sure there are a lot of developers in the audience today, and fundamentally, you would probably all agree that there is tool fatigue. Developers don't need yet another dashboard to look at. What they want is guidance in their existing tooling as they're making architectural changes in Terraform. And so fundamentally at Oak 9, this has been kind of a guiding principle of ours. And we want to fit into that developer's life, into their workflows as early as when they design these architectural changes in Terraform, as they commit those changes to code repositories, as pipelines kick off, and they use Terraform Cloud to then deploy these architectures to their respective cloud environments. And fit within their workflows, give them the guidance as they're building these architectures, fast and frequent guidance as opposed to post-deployment after they've already delivered something. The other kind of common set of challenges that I see is a lot of organizations really focus on building modules, using Terraform modules, and templatizing those modules. And oftentimes security is engaged in really helping build those modules. And the challenges they face when they kind of adopt this approach is really, it's very hard to keep up with cloud service providers, and it's very hard to keep up with the Terraform provider changes as well. If you're in an organization that really embraces developer freedom, fundamentally, that means that you're going to have a lot of different modules in your module repository, and it becomes that much harder to then manage the life cycles of these modules and really have some governance over those modules and how they get used. In organizations that really embrace developer freedoms, developers then are free to change those modules as they ingest them into their own workflows, into their own projects. And fundamentally, that creates challenges for security again. And so there's a lot of, kind of the organizations that do this right really focus on templatization and building modules for common patterns, for commonly used cloud resources. And they have partnerships across the key stakeholders. They've thought through when it makes sense to have something centralized, when it makes sense it needs to be distributed across different business units or different development teams, as an example, so that development teams have the necessary tools that they need, the patterns that they need to really build off of very quickly. And, those challenges with modules really kind of highlight this next point that I want to make is really in modern development workflows, security as code is really the only way to secure these workflows. As you build these application architectures at these massive scales, as you have large development organizations that might have tens of thousands of developers, hundreds of thousands of code repositories, millions of secrets, at the scale that a lot of the companies that we work with operate, it is impossible for small security teams to really, force multiply and provide guidance across the entire application portfolio. And security as code is really the best way for organizations to codify the best practices, the design patterns that they want to follow in a seamless manner without necessarily requiring that security engineer to have expertise in every single cloud capability that may exist, but really focus on the security aspects of that design pattern, and then use automation and use platforms like ours to then fit into that developer's workflow and provide guidance to that developer as they're building a given application architecture for a given cloud deployment. And fundamentally, what that does is it allows security to operate autonomously from development, but at the same time collaborate effectively and then share responsibility around security. So going back to democratizing security for those developers. And what we've done at Oak9 is really we've built a catalog of these security best practices in our security as code framework. And what that does is it allows, similar to the benefits of Terraform from an infrastructure as code standpoint, we can provide cloud agnostic and reusable security architectures that are based on industry standards like NIST, Cloud Security Alliance, AWS's reference architectures, Azure, GCP. And out of the box, they'll support your compliance needs, and you can tailor them for your own use cases. But more importantly, what it does is using security as code enables developers to actually share ownership in security. They can tailor and make changes to the security architectures that they are adopting, and they can have a role to play without actually being security experts. Kind of the last most common, or one of the other most common challenges I'm seeing is secrets management. So I want to kind of talk about a conversation I had just a few weeks ago where there's an organization that really kind of is embracing developer freedom. As part of that developer freedom, developers really control the vault for their application. As they use, Vault to manage secrets, they can create new secrets. And what they have is secrets across potentially 10,000 application teams that have sprawled to a point where security really has little governance over all of the secrets that are created, as well as the policies that are being attached to those secrets. And Vault is a great solution to help manage secrets at scale. But to complement what Vault is doing, what you really need is your security design pattern around, how secrets should be generated, as well as what is the right access control policy for a given secret defined, and those guardrails being defined in security as code. And so a security engineer can really build these guardrails once and then reuse them across hundreds of thousands, millions of instances where these secrets get generated. And finally, what I see with modern security practices is they think about what success looks like first. They think about the right metrics, and they build their security practices to achieve these metrics. So a modern security practice, in my experience, observes and measures these kind of 5 major categories of metrics. They measure the velocity of delivery. And so how quickly is security engaging and providing guidance? How much is security really increasing the deployment frequency of that development team and improving that developer's productivity? They measure velocity of resolution. So, how quickly can security resolve security issues? How quickly do they get resolved? Is the developer armed with actionable, achievable, and applicable guidance that they can quickly fix security issues? They look at, reducing the security cost and really avoiding the cost of finding issues after the fact. So when you do a pen test, for example, you can measure the security quality of delivery, and you know that you're seeing that many less issues in production or your deployed environments than you would have before. And finally, they measure collaboration. They invest in security champions programs. They invest in developer champions programs, and they really focus on measuring how well development, security, and ops is collaborating in their organizations. So what I'm going to do is shift to a demo. So Alex, I'm assuming that I'm still sharing, but please post something in the chat if I'm not. And I want to jump to an example here. So what I have here is a very simple example where I'm deploying an API gateway and some APIs within AWS. Pretty standard Terraform. And what I'm going to do, in the interest of time, I'll make some small change here. I'll remove this comment, and I will change. And create a poll. I think I already did, so let's see here. So if I look at my pull request, what I'm seeing is, let me go back. All right, let's compare, create the pull request. Yeah, so it's going and analyzing the changes. And what should happen is, I guess my run task is not properly integrated here. Let me go back and see. I'm in the wrong repo. Apologize. All right. Did not pray to the demo gods today. Let me go ahead and make a change. So comment, create a new branch. And then so this repo is integrated with Terraform Cloud. And I'll show you what that looks like. And what's happening right now is I've integrated Oak9 into my lifecycle. Oak9 is analyzing the infrastructure as code, translating it into an application architecture, and then our security as code blueprints are being used to assess this architecture for security and compliance gaps. And as we identify compliance gaps, then we're proposing changes back to the developer as code changes. And so what you're seeing here is we found some issues. Looks like those issues. And if I go to this project and I look at, let's see. Let me see if I can. I must not have configured this project properly. So let me kind of shift to this view, and I can show you what we found here. So what I've done is from the Oak 9 console, I've integrated Oak 9 across this entire development lifecycle. So starting from the code repo into that GitHub code repo, but then creating run tasks within Terraform Cloud, which will then deploy into dev. And then from dev, that workload gets promoted to stage, where if we identify issues, we'll create Jira tickets, and then into production, where if we identify issues there, then we'll create Slack notifications for both the dev and security teams. And if I go back to what we just ran, so this was just a minute ago, what we found in that repo is we found a bunch of design gaps. I'll remove some of the low design gaps and apply that change just to minimize here. So we found some significant design gaps. Here's an example where what we did is we found that, okay, backups were not being performed properly. And we're identifying what's the issue, what's the impact if we don't fix this issue, what specifically do we need to do to fix this issue? But more importantly, what is the guidance that AWS has on how do I go about creating backups and point in time? And so fundamentally, we're arming this developer with information that helps them very quickly address and resolve this issue and address these issues early in the development lifecycle so that the cost of addressing these issues is not astronomical after the fact. So I'm going to pause here. I'm going to see if there were any comments or questions along the way. All right. Well, I hope you enjoyed the conversation. And check us out at oak9.io. You'll hopefully do a better job configuring your Terraform Cloud run task than me. And reach out at hello@oak9.io if you have any questions.